Okay, today we're going to talk a little bit more about what we can find out from the graph of a function. We've got this function f of x. You're going to learn that this is, when it has this kind of shape, it's called a cubic. And what we're going to focus on, first of all, are these points here where the graph crosses the x-axis. Those are called the x-intercepts. And what we know about the x-intercepts is that at every point here, we have different x values, but we have only a single y value possible, and that y value is 0. So at every point here, well, let's say this is 2.5 in the x coordinate, but the y coordinate is going to be 0. This one here looks like it might be a minus 1.2, but its y coordinate is 0. This one here looks like it might be a minus 4, but its y coordinate is 0. In every case, these x coordinates have a y value equal to 0. And what is nice about that is we solve for those points by setting f of x equal to 0. Because remember, y is equal to the functional value at x. So here's an x-intercept, here's an x-intercept, here's an x-intercept. Here is a y-intercept. And what's interesting about this point, whatever it is, you know, it could be the y value here is like a minus 3.5 perhaps. I'm just guessing, but I do know this. The x coordinate is 0. It lines up with that origin right there. The x value right there is 0. And that is simply where y is equal to f of 0. We simply plug in 0 wherever we see x in the slot, whatever our function is. Let's suppose that our function here is x cubed plus 3x squared minus 2x minus 19. We would basically put a 0 in every place we see. Yeah, let's make this a minus 3.5. We'd have a 0 cubed plus 3 times 0 squared minus 2 times 0. All of those are 0. Very easy to calculate. And finally we have a minus 3.5, and that's where we get that crossing. It'd be interesting if you actually plugged this function into your Desmos calculator and see what it looks like. It's probably going to look something like this.